Okay, let's take a look at some of these intermediate problems. These are the problems from the homework. So they'll be similar to the ones that are on the quiz. I've been thinking about making this for a while, like some kind of like electronic video solutions manual. I think it could be a little bit better than reading through the regular solutions manual, although that can be good for you too. But yeah, I'm definitely doing this because I know there's some issues getting some kids over here during homeroom this week. And everybody and their mom is needing some help on some stuff. And a lot of kids have been sick. So I think this will be helpful. Anyway, this is the Alice problem. Alice is growing in size. Her initial height is 24. And her height 2 is 5. That's kind of the relationship, 24 to 5. So we're definitely shrinking here. And then height 2, if we think of that as being 1, then height 3 is 12. So it's definitely a grow. But it's kind of hard to compare these two because you'll notice this one is treating it as if height 2 is 5, and this one's treating height 2 as if it's 1. They're the same height. We're just using two different numbers here because they compare differently. So what we're going to do is we're going to try and combine these ratios here by making it kind of an apples to apples comparison. Maybe this is like she's 24 apples tall and she's 5 apples tall. Whereas this is, well, she's 5 apples, or you could think of it as 1 chair tall. Right, and this would be 12 chairs tall. So what we need is them both to be apples, in this case, literally, I guess. And then over here, we know height 1 compares to height 4 this way. So we know the tallest height is 10 feet. Question is, which one is actually the tallest height? Because that one will actually be 10 feet. And then the shortest, we want to know how tall they are in feet. We got to figure out which one's the shortest. So to figure out the tallest, we need some apples to apples comparisons. I guess the first thing would be, let's make these the same thing. So if you notice, these are ratios. So you can think of height 1 over height 2 instead of thinking of it as a ratio like this. Here, let me use thicker pens. And we know that this ratio is 24 to 5. Now, without changing this problem, I can multiply this by 2 over 2, 3 over 3, 4 over 4, and I'll get a relationship that is equal to 24 over 5. And we're going to use this fact to help us out because we know height 2 to height 3 is going to be 1 to 12. So if you notice, height 2, we're thinking of this as 5. Well, what if I times this by 5 over 5? That won't change anything. What it will do is it will allow us to see this relationship as 5 for height 2, which is the same as this, to 60. And 5 to 60 is the same thing as 1 to 12. But now it's really easy to compare these guys, right? I can take all of these heights, and I can actually write a ratio. That's going to be kind of hard to see. Let me grab a different pen. So height 1 to height 2 to height 3, I can now compare them all in one ratio now. And that's why these little like colons and ratios are really helpful because you can do multiple ratios, not just 2 things. You can do 3 things and more. We know height 1 is 24 when height 2 is 5. And when height 2 is 5, we know height 3, when height 2 is 5, we know height 3 is 60. So we can clearly see which one's the biggest, right? Height 3 is the biggest in this problem out of those 3. But we also have this right here, right? So let's just look at this. Well, clearly you can see that height 1 is taller, right? It's 16 units versus 1 unit. So height 1 is taller than height 4. Cool, that means height 4 would be somewhere over here and it would be kind of small, right? Now, I don't need to necessarily compare those right away, but I can tell that height 4 is the smallest. So height 4 is the smallest. And then if you look at these numbers here, you can tell that height 3 is the largest. So if we were actually to write these in order, it would go height 4, height 2, height 1, and height 3. But for ratios, they don't have to be in any order. So we know that height 3 is actually 10 feet. It's actually 10 feet. So if we wanted to rewrite all of this, height 4, height 1, height 2, height 3. We already said that we know this is 24, when this is 5, when this is 60. Let's figure out what height 4 would have to be to kind of pile on here. Well, we need to be able to compare it to height 1 that's 24, right? Well, we have this, 16 to 1. So what can we times 16 by to make it match 24? That's kind of what we did here, right? We knew height 2 is 5, and this is 1. So if we times it by 5, now they compare, right? They're going to be the exact same number. So how do I turn this into a 24? And then whatever I do there, I'm going to do to this as well. And that'll tell me what height 4 should be in comparison to this. Well, it's kind of a tough question, right? What do you times 16 by to get 24? But if you've taken my class, you should know that if we times by a fraction that has 16 in the bottom, that'll divide out 16, because it says divide by 16, and that'll get us 1. And of course, if this is 1, 1 times what gets you 24? Well, 24. So this is the fraction we need to multiply by. It will divide out the 16, making it a 1, and it'll times it by 24, which will make it 24. We're going to do that exact same thing over here. And in this case, we just times by 24 and divide by 16. 1 times 24 is 24. And when we divide that by 16, we get 24 over 16. Now we can simplify that fraction if you want, right? Instead of writing 24 over 16 compares to 24. 24 and 16 both share a factor of 4. So we can rewrite that as 4 times 6 over 4 times 4. And the 4's will divide out. And you might notice that 6 and 4 share a common factor, right? 2 times 3 over 2 times 2. So the simplest way to write this height is that it is 3 over 2. So here are different heights, okay? Now, they're not necessarily in feet, because we know that H3 is the tallest, and it's supposed to be 10 feet. So now let's convert all of these to feet. We know this should be 10, right? Well, in order to not change the relationships, notice we divided by 6 to get here, right? That's going to make it actually 10 feet. So we're going to divide everything else by 6 as well. 5/6. This becomes 4. And if we divide this by 6, we get 3 over 12, right? Dividing by 2 and dividing by 6 is the same thing as dividing by 12. So we know our tallest is 5 feet. Our next tallest will be 4 feet. The next tallest after that is 5/6 of a foot, which is 10 inches. And then this, you might notice, is 3/12 of a foot, also known as 3 inches, right? So you could represent this as 3 inches for the smallest height, or you could represent it as 1/4 of a foot. Either way, those are the smallest height values. So let's back this up and go over it again. It's kind of involved, right? We have all these ratios, and originally they weren't really comparable, right? We had height 2 being 5 and 1. So what we did is we tried to get them all compared, right? We tried to get them to match up. We know if this is 5, if we want to treat this like a 5, well, then we had to times it by 5 to get there, and we'll times this by 5 as well. So we have 24 to 5 to 60 is our ratio, 24 to 5 to 60. Once we have that, we can try and get these guys to match, right? Height 1 is 24, let's make this 24. Timesing by 24 over 16 gets us it, so we'll times this by 24 over 16. So this is going to end up being 24 over 16, we said. And then we turned all of these, we simplified this down, right? Simplified this into this. And then we turned all of these into 10 feet, or into feet. Dividing by 6 was the way to get this to be 10 feet, which we knew it was. So we divided everything else by 6, and that got us our smallest height. So it's a bit involved, right? Label them all out, figure out which one's tallest, which one's shortest, make sure you're doing an apples to apples comparison. Write out your ratio, and then turn it to the numbers you know it's supposed to be. It's supposed to be 10 feet here. So what does that mean for everything else? All right, that's one of the harder intermediates. Let's go for an easier one. 621, this is the one about big town and small town. We've got men and women in both. We know in small town, the ratio of men to women is 3 to 2. So there are more men in small town than women. And in big town, it's inverted, actually, in this case. We know that it's a 2 to 3 relationship. So there are more women in big town. We also know big town is 3 times as large as small town. And we want to find the ratio of the men to women combined. So in other words, what we want to find is total men after we combine the two towns versus total women. This is what we want to find. So we need to know the ratio of total men to total women. Well, if the towns were the same size, we could just say, oh, it's 5 men for every 5 women. Okay, a 1-to-1 relationship. But we know something else. We know that big town is 3 times bigger than small town. So actually, what we're going to have is this. Notice that small town, at minimum, is 5 people. Right? We need to pair people up like this. For every 3 men, there are 2 women. So there's going to be groups of 5, right? With 3 men and 2 women going to be in that group. That means we could have 5 people in the town, 10 people in the town, 15 people, right? And you'd be able to tell me how many men and women there are. Now, this looks also like it would have 5 people, but we know it's 3 times bigger. So actually what this is going to be is really it's going to be a ratio of 6 to 9. And I know that simplifies to 2 over 3, but because it has to be 3 times bigger, and it also has 5 people in it, right? So we need it to be 15 total people, which is what this will be, 15 total people. We know that the minimum number of people in a group has to be 15, right? Minimum number here is 5, minimum number here will be 3 times bigger, 15. So now when we put these together, the total men in small town will be a ratio of 3 to 2 with the women. So 3 men, 2 women. And when we add those towns together, there will be a ratio of 6 to 9 men to women in big town. So for every 3 we have here, we have 6 men. And for every 2 we have here, we have 9 women. You'll notice that this is 5 total people from small town, and this is 15 total people from big town. So it is 3 times bigger. But our ratio is going to be 9 over 11. So for every 9 men, there will be 11 women. So what we're doing here is we're basically saying, okay, here's our ratio, here's our ratio. They both have 5 people in the town. However, this should be 3 times bigger. So it should have 15 people in the town. If we have 15 people, 6 of them will be men, 9 will be women. If we compare these 9 over 11, that's going to be them in total relationship. 622. I have a bunch of coins, and 2/7 of them are nickels. The rest are pennies. If I remove 84 pennies, then now 1/3 of the coins are pennies. So we're going to create 2 different equations here. The first equation is going to represent this. I have a total amount of coins, and 2/7 of them are nickels. So if I take the total, and I times it by 2/7, we know that'll be equal to the number of nickels. So let's say n is the number of nickels. Well, the question is, how do I represent the total number of coins? They didn't tell me how many coins I have. But I do know that it's just nickels and pennies, right? That's what I was saying earlier. So the number of nickels plus the number of pennies will be the total. And 2/7 of that total will be nickels. Now, for this part, if I remove 84 pennies, well, we had our total. We removed 84 pennies. Okay, we removed 84 pennies. This is our new total. 1/3 of the remaining coins, so 1/3 of our new total, will now be the pennies left over. Now remember, P was the pennies we originally had, right? But we removed 84 pennies. So it's not going to be equal to P. That's the original amount of pennies we had. 1/3 of the remaining coins after we removed 84 pennies will be equal to the pennies we have left over. So pennies minus the 84 we already removed. So here's our total. We're taking away 84 coins, right? All of which are pennies. 1/3 of that new total will equal our new amount of pennies, right? Pennies minus original pennies minus 84. So here are our 2 equations, and this should feel a lot like Chapter 5 after this setup. So what we're going to do is we're going to simplify these equations as much as possible, and then we're going to do some elimination substitution. So let's take that purple equation. If I times this and this by 7, this term right here, this is all one term, and this by 7, I end up with 2 times the quantity of n plus p equals 7n. And then if I simplify this further by distributing, I get 2n plus 2p equals 7. And that means after getting my n's together by subtracting that over, I get 2p equals 5n. So that's a pretty simplified version of that equation. Again, just timesing by 7. This is all one term, so I hit it by a 7 and it's gone. And then I'll divide by 2, or distribute 2 in this case, I guess. Now, for the red equation, we're going to do the same thing. I'm actually going to times this by 3, this entire term by 3. This is 1/3 of something. If I times it by 3, I get the original. So that gets me here. So I times that by 3. I have to times every term by 3. So I'm going to hit this with a 3 as well. 3p. And since this is 2 separate terms, I'm going to hit this by 3. So 80 times 3 is 240. And 4 times 3 is 12. So we're going to get 252. So if we simplify a little bit, getting our p's together, right, and getting our regular numbers together, we can simplify this equation down to make it look a little bit nicer. So this is all adding and subtracting. I don't need to treat it like it's one term anymore. So I can ignore those parentheses. If I subtract p from both sides, I end up with 2p. And I think I'm going to actually add 252. So this is gone. If I add 252 to that, I get the n that's already there, plus whatever negative 84 plus 252 is. Well, if I have 252 and I'm adding it to negative 84, what you can do is you can think of it like this. I have negative 84, and I'm adding 252. Well, that means I'm adding negative 4 to this. So that's going to get me 248. And I'm also going to add negative 80 to that. Well, if you think about it, if I add negative 80 to this, this is going to pull it down by 80. So I'm going to get 188 is what I'm going to get. Or sorry, 168. 168. Take away 40, take away 40, right? That's what I'm doing there, taking away 40 twice. So this is 168. And there are lots of ways to do that calculation. You could also do 252 minus 84. It's the exact same thing. So now we know this and this. And I think they look pretty nice. So here's an equation we're going to use, and here's the other equation we're going to use. Now, you might notice something really nice. We have two variables and two equations. So that's great. But not only that, we know that 2p is equal to 5n. So what if we substitute this 2p for 5n? They're the same thing according to the first equation. And now, why is that a good move? Well, because now it's all in terms of n. So if we subtract n from both sides, we end up 168 equals 4n. And that means if we divide by 4, we get the number of nickels we started with. So if we divide this by 4, 160 divided by 4 is 40, and this gets us 2. So we've got 42 nickels. Now, keep your eye on the ball. What do we want to know here? Well, it's hard to tell with the instructions that I wrote down. It doesn't really ask a question, does it? So let me look up the original question. Just trying to save time. It wants to know how many nickels are in the piggy bank. So we did find how many nickels were in the piggy bank originally, 42. If they wanted to know how many pennies were there originally, well, we know P stands for the original amount of pennies. So all we have to do is times this by 5 and divide by 2 to get the number of pennies originally. If they want to know the number of pennies after we removed it, well, you just take that amount and subtract 84. So again, let's back up and run over it again. 2/7 of the total amount of coins are nickels, okay? And then here we have 1/3 of the new amount of coins after we remove 84 pennies is equal to the new amount of pennies. From there, we're just simplifying. This is chapter 2, chapter 3, chapter 4 stuff. Lots of practice is needed to get used to how to set these things up, by the way. You have to think, like, how do I represent the total? How do I represent after I've removed 84 pennies? These are the types of mathematical thoughts we need to practice more. 623. We know my baseball team won 2/9 of its games. So losing season, not so good. If we lost 15 more games than we won, because, we did lose more games than we won, 2/9 were the wins. How many games do we play this season? Well, let's write down what we know. We want to know the total amount of games. So let's have G be the total amount of games. Okay. Now, if G is the total amount of games, that means it's just our wins plus our losses. So that's helpful. We know we won 2/9 of the total games, right? So we know of means multiply. 2/9 of the total games are going to be our wins. So 2/9 of the total games is W. We also know we lost more than we won. So let's talk about this. This would mean we had a 50-50 season, a 500 season. We won the same amount as we lost, but it's not true for us. We lost 15 more. So this is 15 more than this. It's not equal to W. So if I wanted to make it equal, what would I do? Well, this is 15 more than W. So you can either write it like this. Now they'd be equal. Or you can write it like this. Add 15 more wins, and we would have had the same amount of wins as losses. So here are all the things we know, and this is what we're looking for. Keep your eye on that ball. I guess literally in this case, it's baseball. So how can we set this up? Well, I think there's one other thing that we've forgotten about. We know that if 2/9 of the games are wins, we know 7/9 of the games must have been losses. Let's go ahead and take maybe one of these equations, maybe these two right here, and go ahead and solve them. Now, you might notice that we have G, W, and L. So we have two equations with three variables. That's usually a bad sign. However, don't we know that G is the total number of games played? And that's equal to the wins plus the losses. We can rewrite this top equation. We can write it as 2/9 times the total number of games equals W. And remember, the total number of games is just the wins plus the losses. We also know that W equals L minus 15. So I'm going to write that here. Or you could do W plus 15 equals L. In fact, I think I might use that one. Lots of ways to do this, guys. But I'm just going to use these two. And here's what I'm going to do. I'm actually going to take L, this L right here, and I'm going to replace it with all of this. I'm going to substitute all of this here for L. Because what that's going to do, it's going to put everything in terms of W. And then I can find how many wins we did. And once I know the number of wins, I can add 15 and get the losses. And then I can add those together and get the total number of games played. So let's take this equation and rewrite it as 2/9 times the number of wins plus, well, L is equal to W plus 15. So I'll put this in little brackets right here, little bracket parentheses. It's the same as normal parentheses, just to show you that this used to be L, right? L is this part. We can ignore the parentheses when we're adding or subtracting, though. Just so you can see where that came from, right? That was this part right here. Maybe I should do that in red. So now all we have to do is solve for W. So there's a lot of different things we can do here. One of the things you're probably wanting to do is add all this up together on the inside. This is 2 W's plus 15. And in order to get our W's together, we definitely need to do something about this fraction. Distribute it, do something. Since it's an equation, I'm going to times everything by 9. And that's going to give me this. 9's divide out in the bottom. And we get 9W. After distributing that 2 to everything in the parentheses, I end up with this. Getting my W's together, I can subtract and then divide by 5. So that's the number of wins we had in the season. We only won 6 games. And if you're clever, you can figure out the number of losses, right? The number of wins plus 15 is losses. So losses must have been 21 losses. We want to know, and keep your eye on the ball, we want to know how many total games we played. Well, altogether, that's going to be 27 games. So first thing you want to do when you ever have a problem like this, write down all of the stuff you know based on what they told you. We know we want to find the number of games played, so I should probably make a variable for that. Let's call it G. We know the games played is just G. G will be just W plus L. We know 2/9 of the games are wins. And we know that we lost 15 more games than we won. So if we take 15, remove 15 of our losses, then we'll be equal to the wins. Or add 15 to the wins, we get the losses. We also know that 7/9 of the games will be losses. That's another thing we knew. This is all just true things we knew. And then after we have all these things down, we can kind of find a game plan. And I think our game plan was basically to use this and this, replacing G with this stuff. Once it was all W's and L's, we could solve. All right, let's move on to the next one. 624. This one's really easy if you understand how fractions work. So check it out. We want to know what B over C is. Let's first write that down so we don't forget. B over C. Well, how can we get B over C? We have A over B. They gave us that. And they also gave us A over C, which is equal to 5. Well, in order to get B over C, I think what we need to do, and here, let me turn the brightness up a little bit. I think what we need to do is multiply these together in a way that gets rid of the A, right? Because both of these have A in them and this doesn't. And notice what will be left over is B and C. So maybe there's some way to make that happen. And there is. If A over B is 3/4, you know that you can flip ratios around. We can write B over A as 4/3. And why this is better is because if we take B over A and we times it by A over C, look what will happen. We're going to be able to get rid of our A's. We're going to end up with BA, or AB in the top. We'll end up with AC on the bottom. And of course, we know this is all one term, and it says to divide. Anything divided by itself is 1. So we end up with what? B over C, the thing we wanted, right? We end up with B over C. So this is going to be our game plan. We're going to take B over A and times it by A over C, and then we win. You could have seen that these divide out here as well without combining them first. Remember, you can multiply and divide in any order you want. It says divide by A. This is times by A. This is not cross-canceling or cross-multiplying or anything. It's all one term, multiply and divide in any order you want. It's nothing special here. We've been doing it for a while. This says we're also going to take all this stuff and times by 1, divide by 1, and divide by C. Well, timesing by 1 is B, dividing by 1 is still B. Dividing by C is B over C. So that's our game plan. We're going to do B over A times A over C. B over A is, of course, 4/3. And we're going to times that by A over C, which we know is 5. When we do this, this says we're going to take it 5 and times it by 4 and divide it by 3. Well, that's really easy. Timesing by 4 and dividing by 3 gets you 20 over 3. 5 times 4 over 3. And this will get us B over C. So again, we just write down what we know. We know that we can flip over these fractions and it won't change anything. And what's nice when you multiply these together, A's divide out, right? That'll get us what we want. This next one, we know that the number of fish to bread. So you can trade 3 fish for 2 loaves of bread. We know we can trade 1 loaf of bread for 4 bags of rice. And we want to know, how many bags of rice can we get for 1 fish, a single fish? Now, this might come out to a fraction or it might not. It depends. But right now, it's kind of hard to compare how fish is to rice. We know they both cost more than bread. But it'll be easier to compare it if both these numbers were the same, right? So what are we going to do? This is similar to the problem that we had with Alice. This right here, if we were to times it by 2 and times this by 2, this would not change the relationship. It'd be 2 to 8. And 2 to 8, same thing as 1 to 4, but it allows us more easily to see what's going on here. 3 to 2 and 2 to 8. We now know that we can write a ratio like this. For every 3 fish, we'll get 2 loaves of bread. And for every 2 loaves of bread, we'll get 8 bags of rice. So now we can simplify this ratio just to the thing we care about. Fish to rice. We know it's 3 fish gets us 8 bags of rice. Now remember, what they want to know is not how many bags of rice we get for 3 fish. They want 1 fish. So how do we take this ratio and turn it into that? Well, if you think, to get from here to here, don't I have to divide by 3? Which means if I divide both by 3, it won't change the relationship. I'm dividing by 3 over 3, essentially. So this becomes 1, and 8 divided by 3 becomes 8/3. So we get 8/3 bags of rice. That's 2 2/3 bags of rice for 1 fish. So again, it's kind of similar to Alice's problem. We need to get an apples to apples comparison. If we times this by 2, we need to times this by 2 so the relationship doesn't change. Timesing by 2 over 2 doesn't change anything. Once the relationships are apples to apples, right, same number here, we can connect them. And once we know 3 fish is 8 rice, divide that by 3 and we'll get how many rice we get for 1 fish. 641. What number is 5% of 10% of 1,200? Well, you know percent means per 100. And you know of means multiply. So we're going to take 5% of 10% of, that's another multiply, 1,200. And from here, it's just, there's a million ways to do this. You can multiply across and get 50 over 10,000. You can make this 50 and divide it by 100. There are a million different ways to do this. It's all a matter of what makes most sense to you. Now, the way you do it has to actually be true. You can't just be like, oh, cool, all of this stuff crosses out and I get 7. Right? It has to actually be mathematically sound. But there's a million ways to do this. I think what I'm going to do is I'm actually going to do this. I'm going to notice this is all timesing and dividing. It doesn't matter what order we do it in. And this is my biggest number. So I'd love to divide it down and make it smaller so it's easier to calculate in my brain. So what I'm going to do is I'm going to actually take this and divide it by 100. Notice this says this times 10 divided by 100. You can do it in any order you want. If we divide this by 100, Well, we're going to get 12 over 1. 1,200 divided by 100 is 12. Now, you might also notice here, we have 10 times 5 over 100. And we can divide first, right? This has a factor of 10 in it. But I'm actually going to do 5 times 10. That's going to get me 50 over 100. So what I end up with is 50 over 100. So I times by 10. I took this and times it by 10. Then I was supposed to, after I times this by 10, divide it by 1. Okay, cool. Did it. That doesn't do anything. And then lastly, I have to times it by 12. Well, I can simplify 50 over 100. They both have a factor of 50. 50 times 1 and 50 times 2. And because it's all timesing and dividing, I can do it in any order I want. These 50s become 1s, and I end up with 1 over 2 times 12. And of course, what does that mean? It means times by 1 and divide by 12. Well, that's 6. So our answer is 6. No matter how you do this, timesing here first, putting these together, making 10,000 on the bottom, dividing this by a bunch, right? No matter what you do, as long as you don't break the actual calculation, right? You do legal mathematical moves, just cross it out and write 13. You should always end up with an answer of 6 here. Notice it doesn't matter whether we do 5% or 10% first. We could have flipped these because it's all multiplication. So 10% of 5% of 1,200 is the same thing as 5% of 10% of 1,200. But also notice that it's not 15% of 1,200. You can't just add these, right? Of means multiply. Next one, 651. We got 2 guys going out to eat. They both tipped $2, which is not a very good tip, regardless of how much money you spent. But apparently, Mike tipped 10% of his bill. I crossed all these out because I was actually writing the ones from the quizzes on accident, but I want to give you the ones from the homework. Mike tipped 10% of his bill. So 10% of his bill was $2, okay? And Joe tipped 20% of his bill. So 20% of his bill was $2. So you might be able to figure out Joe's bill must be twice as big, right? Mike's bill must be twice as big, right? It only took 10% to get to 2, whereas this one took 20% to get to 2. We want to know the difference between their bills. So let's find that. The difference between their bills will be something like Mike minus Joe equals the difference, right? This is what we want to find. And we know Mike's bill should be bigger. Only 10% is what it took to get to 2, where you had to do 20% to get to 2 here. So let's find Mike and Joe's bills. Well, we know that if you take Mike's bill and you take 10% of it, 10% of Mike's bill is equal to $2. We also know that 20% of Joe's bill is equal to $2. Well, we can rearrange this and solve for Mike and Joe's bills. Let's go ahead and do that. This is 1/10, right? This is 10 times 1, and this is 10 times 10. 2 of those 10s divide out, 10 and 10. So we have 1/10 of Mike's bill is $2. Here, 20 over 10, well, that simplifies to 2 over 10. And from there, we can simplify further. Here, I'm going to times by 10, and I'll get 1m. That's what I want. Timesing by 10 gets me m. 10s divide out, and I get 20. So Mike's bill must have been $20. And that makes sense. 10% of $20 is $2. Over here, I'm actually going to divide by 2 first. When I divide by 2, I get 1/10 J equals 1. And that means 10% of Joe's bill should have been $1. So if I times by 10, it reveals that Joe's bill was actually $10. So what is the difference between their bills? Also $10. $20 minus $10 will be $10. So what am I doing here? I'm setting it up. 10% of his bill was $2. 20% of his bill was $2. Then I'm just simplifying my fractions and then simplifying and solving for m and j. Once I've got that, I need their difference. Now this one's a little bit tricky on the words, but the setup is kind of easy. Each day, 20% of the fish are sold. So if I started with 100 fish on day 1, I would reduce it by 20 and get 80% or 80 fish left over. And then on day 2, I'd take 20% of 80 and I'd remove that, right? Well, we didn't start with a number that they gave us, right? We actually want to find how many did we start with on Monday? Because at the end of the day on Tuesday, after 2 work days have gone by, 2,000 fish are all that's left. So here's what we're left with, 2,000 fish. However much fish we started with, we lost 20% at the end of Monday. So how much was left over? If we lost 20%, well then 80% of the fish are left over. So at the end of Monday, 80% is left over. And then we get some number here, right? This will be some number. That's what's left over on Monday, what's underneath my fingers. Well then at the end of the day on Tuesday, we lost another 20%. So here's what we had on Monday. If we take another 20% away, 80% will be left over. And what will be left will be 2,000 fish. So basically what we're saying is, I'll have 80% of our fish left over on Monday, and then 80% of that will be what's left over on Tuesday. So we're basically just taking 80% of it twice. We're reducing it by 20% twice. So what was the original amount? Well, that's going to be F. Let's solve for it. This is clearly 8 over 10. And I can simplify that further if I want. Let's go ahead and do that. If I take out a 2 from both of these, we get 4 over 5 and 4 over 5. Now, we could go ahead and multiply these together and get 25 and then times by 25 over to here. There are lots of things we could do. I'm actually going to divide first. Let's divide this entire term by 4. Since this is all one term, dividing one of these by 4 gets it done. If I divide this by 4, then I end up with 500. I'm going to divide by 4 again. So this entire term, if I divide it by 4, I end up with this. 500 divided by 4 is 125. So now if I times this by 5, this becomes a 1. And this becomes 500 plus 100, that's 600, plus 25, 625. And if I times by 5 again, by the way, this F times 1 is just F. If I times by 5 again, then this becomes a 1 over here. So timesing by 5 again, we get 3,000 plus 100, 3,100, plus 25, 3,125. So F, the original amount of fish, should have been 3,125. So the setup is key here, right? I know if I reduce the original amount, we'll call the original amount F, that's what we're looking for. Let's fix this. If I reduce the original amount by 20%, that means 80% is left over. So I need 80% of the original. And then I reduce it again, so I need 80% of that. After I've reduced it by 20% twice, I'll have 2,000 left over. The rest of this is just simplifying fractions and multiplying move across. I think a really common mistake is thinking that dividing by 4 gets rid of both of these 4s. But remember, if I had something like this, 5 times 2 times 2. If I divide this number by 2, it doesn't get rid of both 2's and get me 5. If I divide it by 2, it gets rid of one of the 2's, right? Same thing here. If I have F times 4 and I divide it by 4, one of the 4's will become a 1. Same thing here when I times by 5. One of the 5's will divide out. The other one will stay behind. So I have to times it by 5 again. You could have also just times this by 25 since we're dividing by 25. That would have get rid of both of them. All right, 6, 5, 3, and we're getting close to being done here. I think we only have 2 more. 3 more. A solution of 20% acid and 80% water. I'm throwing off the white balance with my hands here. Let's change this a little bit. 20% acid and 80% water is mixed with a solution of 50-50. If twice as much as the 50-50 solution is mixed with the 20, what ratio of acid to water is produced? So the last thing is what we need to grab onto. We want the ratio of acid, so total acid over total water. This should feel similar to the big town and small town problem. So we need the total amount of acid. Well, we know We've got 20% acid, right? 20% of the solution is acid. In fact, let's do that. 20% of the solution. I don't know how much we're using for the first amount. Maybe it's like a gallon of it. I don't know. Let's have S be the amount we're using. 20% of the solution is acid. Well, if you think about it, how much of the solution is acid for the other one? Well, 50%. Except it's not going to use the same amount. So if S was 1, like it was 1 gallon, if S was 1 gallon, this would be 2 gallons. If S was 5 gallons, it would be 10 gallons. So if this is S, this is 2S, twice the amount of solution. And that's going to be our total amount of acid. 20% of the solution plus 50% of the solution done twice. Now, how much water are we going to have? Well, in the first solution, we have 80% water. So 80% of the solution is going to be water. And we're going to add that with the amount of water from the other one. Well, 50% of that solution is water. Remember, we're going to do it twice. So it's twice the amount that we did here. So 2S, if this is S. If we put these all together, you might notice we get 70% of 3S. Let me make sure I agree with that. Hold on. Yeah, I don't agree with that. Sorry. Let's multiply these. I get 20% because this is 2S, that's S. They aren't the same. They aren't like terms. But they will be in a second. 20% of the solution plus 100% of this solution, because 2 times 50%. And that might feel weird to you, but it does make sense, right? If half of the thing was water and we do it twice, it's almost like we had the entire thing be water, right? We had an entire thing of water and an entire thing of acid, and that's what we're going to see here. So this is 50% acid, and we're doing it twice, so we're going to get 100% acid. But we're also going to get 100% water on the bottom, as you might notice. 100% water. So an entire solution of acid, an entire solution of water. 20% of the solution will be acid, 80% of the solution will be water. So if we add these together, we get 120%. We can do this now because they are both in terms of S. Same thing here, we can add them 180% of S. And you might notice a lot goes away. This is all multiplication and division. So the amount of solution doesn't even matter. It divides out, right? And the percents don't matter either. We end up with 120 over 100 over 180 over 100. And how you can deal with this is this. I'm going to times by something that won't change the problem. So I'm going to times by 1. And what I'm going to do is I'm going to multiply by 100 over 100. And what that'll do is if we just think of the top, these 100s will divide out to 1s. And we'll get 120. And if we just think of the bottom, 100 times this, 100s divide out to 1s. And we get 180. So notice I times by 1, it didn't change anything, so we know this is the same as this. And now I've got my ratio, 120 to 180, which of course we can simplify to 12 over 18. And we can simplify further. They both have a factor of 6. This is 2 times 6, and this is 3 times 6. 6 is divide out, we get 2/3. So 2/3. 2 parts acid to 3 parts water is our answer here. There you go. So this is similar to the big town and small town problem. We're going to get the total amount of women or the total amount of men, but in this case, it's going to be acid and water. So we have 20% of some amount of solution, acid, and we have 50% of 2 parts solution being acid. In total, that's going to be our total acid. In the bottom, we have 80% water of 1 part solution, and we have 50% water of 2 part solution. So in total, that'll be your total amount of water. Simplify. Right. 2 more, I believe. Okay. So we know T is 25% of U. I'm going to write that out. T is 25% of U. And we want to know what percent, so I'm going to do this, what percent of 4t is 2u. This is what we want to find out. Well, we definitely have too many variables, right? We have two equations, but 3 variables because of that x. So maybe one of these variables goes away. Also, there's a way to think about this and kind of figure it out. And we'll talk about that afterwards, I think. So first off, I'm going to simplify this. T is a quarter of u. 25 over 100 is just a quarter, right? 25 is divide out. Now, if we knew, like let's say we times this by 8, we would make this 2u, and we could switch out 2u for whatever t is. I think that'd be a really good idea. So what I'm going to do is I'm going to times this by 8, every term by 8. And what we'll end up with is 8t. 8 and 4 divides out to 2, that's why I did it, and I get 2u. So 2u is the same thing as 8t. We can substitute this for 2u in the other equation. So this becomes x over 100 times 4t equals 8t. Because 2u is the same thing as 8t. And why that's good is because it got rid of one of our variables, right? We substituted it out. Now, if we divide everything by 4t, dividing this by 4t becomes 1. So 1 times x over 100 is x over 100. Dividing this by 4t, well, I'll write it out, just in case you're weirded out by it. But basically what will happen is 8 divided by 4 is 2, and t divided by t divides out. So notice all of our variables went away. We were able to solve this. So now we have what percent is equal to 2, right? And you might think, oh, well, 2% is equal to 2. If x is 2, 2 divided by 100 does not get us 2. Why do you divide by 100 to get 2? 200. So x is 200%. It's 200%. That's how they relate. Now, there is a way to think about this, right? T is 25% of u, so it's a quarter of u. Well, what is it of 2u? How does t compare to 2u? Forget about 4t. How does t compare to 2u? Well, if we doubled what u is, t is going to be half of what it was before. It's going to be 12.5%. And if we take that and times it by 4, we can figure out from there what 4t would be in relation to 2u. Yeah. But I think, especially since the numbers are going to be changing for these problems, it's going to be kind of hard to see it, right? If that's a random percent, it's going to be kind of harder to just do this stuff in your head. So I think the main key is set up what it says here. T is 25% of u. And we know, I guess I'll do that in red. We want to know what percent of 4t is 2u. So this is kind of like two basic problems jammed together, and that's really what intermediates are, right? It's not that they're necessarily harder, it's just that they have multiple topics happening at the same time. So we simplified this down to be able to substitute, and then after we did so, we divided to get x on its own. All right, last one. 655. 20% of the students walk to school. If the number of walkers doubles, what fractions of the students are now walkers? Now, be careful. You might think, oh, if we double the number of walkers, we just end up with 40%. Well, let's take that a little bit further. Let's continue that logic. What if I take the number of walkers and times it by 5? Does that mean 100% of the students are now walkers? No, right? The people that didn't walk before are still not walking. So this times by 2 idea of, oh, I'll just double that and we'll get our percentage, ain't gonna work. So we need something else. 20% of the students walk to school. Well, that means 20%. 20 would walk out of 100 total. Okay? If we double the number of walkers, that would put us at 40 walkers. But it wouldn't be out of every 100 people. Think about it. If we double the number of walkers, we used to have 20 walkers out of 100 total people. But now we doubled the number of walkers. So we had 100 total people before when this was 20. When this is 40. Didn't we just add 20 more people? So the new total is 120. Oh, look who it is. I'm recording a video for you right now and a couple other people, but come on in. I'm recording, yes. Welcome, special guest Emma. You're here early. So what fraction of students are now walkers? Well, it's 40 out of the 120 total because we just added 20 people. And of course, that's going to be 1/3 is the fraction, is what that simplifies to. So that's 655. Just in time, I just went through all of the questions you probably have. And it only took me an hour. So is it an hour? How long is this video? 50 minutes.